Hi guys, for the fourth lecture of chapter 12, we're going to be going right off of the groundwater pollution that we ended with in chapter 12's lecture 3 for water uses. And now we're going to go straight into water pollution, specifically surface water pollution, be it in lakes, rivers, streams, or in the open ocean, all of which are a huge problem. So going a little further, pollution and water pollution is generally defined as the release of matter or energy into a water body that causes undesirable impacts on health and well-being of humans, health and well-being of ecosystems, as well as specifically aquatic organisms. And this can take a variety of different forms. Normally, it is going to be some sort of material or chemical that causes the problems, but it can also be energy pollution or a sort of solid such as plastic pollution, which is more and more frequently causing the majority of the problems. It seems like every day now we are getting a new source or a new news article talking about how another whale or dolphin or sea turtle died from ingesting just God knows how much plastic. So moving forward, there are two basic types of pollution, and we're going to be revisiting this for every time we talk about pollution, be it water pollution, air pollution, or another form of pollution, and that is going to be the difference between point source and non-point source pollution. Now, we talked about this just a little bit when we were discussing groundwater pollution in the water uses lecture, the previous lecture for this chapter, but point source pollution is simply pollution coming from a single identifiable source. Think of this on the basically the top right hand side of your screen when you see that pollution being dumped from a single pipe. That is a point source form of pollution. It is direct, it is identifiable, and it is usually very easy to monitor, to adjust, and to fix if there is a problem associated with that point source pollution. Now contrast that with non-point source pollution. Non-point source pollution is pollution coming from a variety of different locations all at one time. This is a diffuse form of pollution and is something that we were talking about a little bit when we were talking about groundwater pollution because it comes from so many different locations. When you think of non-point source pollution, think of like right below me here where we look at the different forms of fertilizer that come from hundreds of different houses draining into a lake. So when fertilizer comes from a variety of different sources and they're very hard to pinpoint which one is a big offender, it can be known as non-point source pollution, and it is much harder to monitor, control, and fix when there is a problem associated with it. So remember that point source pollution, single location, generally pretty easy to fix if there is a problem associated with it. Non-point source pollution, diffuse, many locations, and can be very difficult to control if there's a problem associated with it. Moving into the different types of pollution, we are going to first be talking about the most readily thought of form of pollution when we are thinking of water pollution in general, and that is going to be toxic chemicals. And these are going to refer to harmful chemical substances which harm or poison aquatic plants and animals. So this can take the form of organic toxic chemicals. These are going to be pesticides or petroleum products that can disrupt different forms of biological processes happening within organisms. They can be inorganic toxic pollution. So this can be things like heavy metals such as arsenic, mercury, or lead, and they can have a variety of different consequences. They can damage environmental health, they can damage ecosystem health, they can wreck biological organisms, and they can impact human health. We can reduce toxic chemicals by simply issuing and enforcing more stringent regulations on industry to punish polluters. It's a point to note that toxic chemicals are usually a point source pollution, not a non-point source pollution. So generally, we have cracked down on toxic chemical pollution in developing nations, particularly in the United States, and it is very easy to identify the source of different pollutants, and so we can regulate industry and punish these different polluters. Moving forward, we talk about nutrient pollution, and we've talked about this at length, particularly in Chapter 2 and moving forward. Nutrient pollution is the process by which too many nutrients, mainly nitrogen and phosphorus, are added to water bodies and can act like a fertilizer or food, causing excessive growth of algae. Remember, we have talked about this at length, and it's a particularly big problem off the coast of Peninsula Florida because every year water from Lake Okeechobee, which is very nutrient rich as a result of all the farmland and fertilizer around it, gets dumped into the peninsula coast, and as a result it triggers a massive algae bloom this last year, killing about 10,000 different organisms. It is extremely toxic. It is a huge problem, specifically because it causes dead zones. zones. Remember that we talked about dead zones in chapter 2. So the harm is that when you add a ton of food for algae, algae is typically very used to a limited food environment. They explode in growth when they do that. Some algae will actually release toxins, although this is more rare. It's more relegated to what we think of when we think of red tide. Green tides or brown tides, which are blue-green cyanobacteria algae or a different form of algae, these essentially are a problem because when they bloom, they all die at once. When they die, bacteria at the bottom of the seafloor will eat them very rapidly. As the bacteria are digesting all of these bacteria or all of these algal bodies, they eat up a lot of oxygen. As they eat up a lot of oxygen, it kills literally everything in the water because anything that uses oxygen to live eventually suffocates. So this has a huge impact because it causes major dead zones. We can reduce nutrient pollution by treating municipal wastewater, something we talked about at length in the water uses lecture, the previous lecture, as well as using phosphorus-free detergents and monitoring nutrient pollution, although it can be very difficult because nutrient pollution is non-point source, meaning it comes from a diversity of different locations and it can be very hard to nail down. In addition, we also have biodegradable waste, which is a related form of pollution but slightly different. This is the introduction of large amounts of biodegradable products, normally feces or some sort of organic substance that is introduced into a waterway. It similarly decreases dissolved oxygen in waterways simply because it creates a dead zone very similar to nutrient pollution. And we can also treat biodegradable wastes by treating wastewater to remove that organic matter before it even enters waterways. So moving forward, another form of pollution that we don't really think about when we think of pollution is actually sediments. Sediments are eroded soils that are carried from rivers and waterways via runoff and deposited along distances very far away from the actual site of erosion. Now, this is a natural process. Sediment is naturally transported from along a river to where the river injects itself into the ocean. However, this can be significantly exacerbated by clear-cutting forests, mining, and any time where we expose farmland or soils. Basically, anytime we relieve the plant matter above a soil, leaving it exposed, leaving that sediment loose and vulnerable to erosion. This can be very harmful if it happens all at once. It can kill fish and wildlife that have adapted to clear, clean rivers and low-flow sediment. Remember that plants need a lot of sunlight, and when there's sediment pollution blocking sunlight, they die because they are essentially starving from that lack of being able to photosynthesize. And we can reduce this pretty easily. We can manage farms better with all the topics that we talked about in chapter 7 with reducing types of erosion, and we can avoid clear-cutting forests by employing the different types of maximum sustainable yield practices as well as ecosystem and adaptive-based management that we talked of in chapter 9. And this can reduce other forms of disturbance as well. Basically, as long as we can limit different types of erosion, we can reduce sediment pollution. Moving forward now, another form of pollution that is very well known is oil pollution, and this is basically the introduction of oil in waterways. And so this is very popular in conceptual, or basically in a social media perspective, simply because we are very well aware of the significant oil spills, the huge oil spills that happened in the past. Huge oil spills were basically a point source of pollution. We knew exactly where it came from, and we knew what the cause was so that we could tackle it. However, these days, the oil pollution from oil spills are actually few and far between. The last one that we actually had was the Deepwater Horizon oil spill that happened in 2010, which was over 9 years ago. So these major oil spills that we think of, Exxon Valdez, Deepwater Horizon, these are actually few and far between these days and aren't the major contributor of oil pollution in our oceans. More recently, it is actually non-point source pollution that are from ocean-going boats and vessels, basically small vessel leaks, especially whenever you look at a marina, you can kind of see all the oil that is leaking out into that marina. Anyway, these non-point sources of oil pollution are the primary source of oil pollution into our oceans. And there's obviously a ton of different problems associated with oil pollution. It destroys habitats. It is toxic to organisms that are exposed to too much. And we can reduce this nowadays by legislation and emphasis on spill and leak prevention and response. So improving the leaks, or improving the capacity to detect leaks in boats, and improving the efficiency of oil usage in boats and ocean-going vessels are now going to be the primary method for actually controlling oil pollution in our oceans these days, simply because the oil pollution from big tankers and oil spills are few and far between these days, because we've gotten so good at regulating those scenarios. Now, perhaps the most infamous form of pollution these days, especially when we look at the news these days and we see about the Great Pacific Garbage Patch, as well as all of the whales, some large mammals, turtles, and other megafauna that are dying as a result of this form of pollution, is nets and plastic debris. Basically, plastic pollution is the accumulation of plastic objects in Earth's environment that adversely affect wildlife habitat, as well as humans. It is basically caused by humans not throwing away their trash, which is the most depressing, stupid form of pollution that I can even imagine. It is ridiculous to think that people just throw their trash in the ocean knowing full well that some organism is probably going to eat it. Basically, the harm is that organisms in the ocean think it's food. They think primarily that it looks like jellyfish, because I don't know if you've ever seen a plastic bag underwater, but a plastic bag underwater looks exactly like a jellyfish. So a lot of organisms will try to eat it, so it will either strangle the organism, or it can poison wildlife by gradually accumulating in their guts. They can't actually get rid of that plastic. Their gut doesn't really have a way to expunge it out of that organism, and so they gradually accumulate and die. It is incredibly depressing that this is such a preventable cause of pollution, and yet we are still doing it at an alarming rate. We can reduce pollution by simply not using plastic products. That is a big movement that is sweeping most industrialized countries at this moment. We can recycle, and we can just throw your trash away. So by not letting it get into the open ocean or the environment, we actually are preventing this pollution in and of itself. However, one of the major problems is that plastic pollution is actually coming from developing countries. When I was working in Cayman, we had an enormous amount of plastic pollution that was coming from Hispaniola, basically the Dominican Republic, and the country of Haiti. And because they use their ocean as a trash bin, the current would collect it and it would wind up in Little Cayman. And it was extremely depressing to see different organisms being choking and dying, particularly sea turtles, that were dying from a very preventable cause of pollution. So in addition to these different material forms of pollution, there are also several types of pathogens that are also typically considered a form of pollution, even though these are biological organisms. Pathogens and disease are disease-carrying organisms which can enter drinking supplies of water. And this is caused by contamination from inadequately treating sewer. And this can cause harm, particularly in people, by sickness and potential death from those who ingest pathogens. One of the big issues right now, especially in Yemen, talking about, again, how they are the first country to actually run out of water back in 2009, as a result of their degradation of their infrastructure and their sanitation systems. They have the largest outbreak of cholera, which is a very preventable sanitation-related illness that is sweeping the nation and has infected over 1 million people and killed thousands of people to date. So these are typically happening in developing countries where their sanitation systems are actually being either destroyed or their infrastructure is not sufficient to control these different pathogens. And we can reduce this by simply treating sewage properly, investing in infrastructure that can treat sanitation before releasing, as well as disinfecting drinking water supplies before we release it back into major water bodies. And then a form of energy pollution that we don't really think about is thermal pollution. Thermal pollution is essentially excess heat that is introduced in waterways. Usually a lot of power plants in a form of non-consumptive use of water. Basically, when we extract water and then we put it back into the waterway, it's used to cool off very hot nuclear reactors and different forms of coal power plants. And essentially it harms organisms because all of a sudden they are subjected to an aquatic heat wave. They Normally, fish and other aquatic organisms have adapted to a very specific temperature range. They are far more susceptible to heat fluctuations than we are as mammals, and as a result, even an increase in temperature of a few degrees Celsius can wipe out a ton of different organisms and cause a ton of different fish kills. We can reduce this by careful management of power plants. Essentially, instead of just releasing that water back into the water body, we let it sit for a while and let it cool off on its own, and then gradually release the water back into the water body so it doesn't overload the river ecosystem with too much heat. Finally, a form of pollution that is very indirect is ocean acidification. And we talked about this a little bit in the when we were talking about the adverse reactions to coral reef ecosystems. Essentially, the ocean, to talk about it at length here, oceans absorb actually about half of all carbon dioxide emitted by humans. So half of it is going into our atmosphere, half of it is actually being readily absorbed by our world's oceans. As our oceans absorb carbon dioxide, it actually reacts with water molecules to form an acidic substance known as carbonic acid. By the way, carbonic acid is the same substance that makes your sodas fizzy. Remember that when you open your soda and shake it up and release it, all of a sudden it goes from that fizzy sensation to going flat. That flatness is when you disturb all of that carbonic acid, and it actually releases all of the CO2, so we no longer have that carbonated sensation because the acidic content is no longer there. So when we increase carbonic acid into the world's oceans, we cause the pH of the ocean to drop. And the pH, or the acidity, remember the H+ ions that we talked about way back in chapter 2, the acidity of the ocean is very important in regulating what kinds of organisms to live there. Remember that if a water body is more acidic in nature, essentially a lot of organisms can no longer thrive in those conditions because they haven't adapted to live in very acidic conditions. It's a form of toxicity that we don't really think about. A particular problem, and again, we talked about this a little bit when we were talking about coral reefs, is that coral reefs and other organisms rely on what are called carbonate ions, so CO3-. Basically, carbonate ions are something they rely on to take out of the water and then incorporate into their shells and other skeletons via calcium carbonate. So they use calcium carbonate to build their shells. When you think of coral reefs, think of the coral reef skeletons. When you think of literally any clam or oyster, the skeleton or the shell of that oyster or clam is made of calcium carbonate. Any crab you've ever seen, basically any organism that builds its own shell is going to rely on extracting carbonate ions and calcium ions from the water and creating calcium carbonate shells. Now, when oceans become more acidic, it makes it difficult, extremely difficult, for organisms to pull out carbonate ions of the water, simply because carbonate ions are now reacting with that acidic carbonic acid, and as a result, organisms are having a harder and harder time pulling carbonate ions out of the water. Eventually, if this continues, water will become so acidic that not only will organisms not be able to pull any carbonate ions out of the water, but actually that excess carbonic acid will react and dissolve and erode the shells of the organisms that currently exist. So this is a major problem. Ocean acidification is called global warming's evil twin brother because it's often unaddressed, and it has the potential to be a far more serious problem as things get worse and worse. Now, this is everything that we have for the water pollution lecture. I know, again, this is a little bit depressing. Bear with me here. We have one more depressing lecture where we are going to be talking about overfishing. It's going to be fairly short, and it's going to be talking about the different forms of overfishing and why it is becoming such a different problem. All right, I will see you for the last lecture of Chapter 12 and Module 3 tomorrow. Take care, guys.